Assalamualaikum. In this session, we are going to learn about nuclear magnetic resonance spectroscopy, or known as NMR. NMR only measure the nuclei of some atoms that have spin. For example, proton 1, carbon 13, fluorine 19, and phosphorus 31. Most of the nuclei do not have a spin. For example, C12 and oxygen 16, and these atoms are not detected by the NMR. Nuclear magnetic resonance principle. Nuclear spin are oriented randomly in the absence of an external magnetic field. As we can see in this figure, the nuclear spin are randomly oriented without the attachment to the NMR. When we put our sample inside the NMR, what happens? They have an external magnetic field with the level of B node, and the nuclear spin now align with the B node or against the B node. Because of these two different states of spin, so they have two different energy. The one who align with the B node is a low energy, and the one against the B nodes is a high energy. The difference between these two different energy contribute to the delta E. So for the atom to have a nuclear spin flip, they have to achieve enough energy equal to this delta E to have a resonance. So means they have to spin flip. So to get the spin flip, the atom have to absorb enough energy. Where the energy can be absorbed, they have two ways, which is we fix the radio frequency of the instrument, and we adjust or change the magnetic field until the atom had enough energy equal to delta E. So when the enough delta E, they can spin flip and resonate, so the signal will be detected. So another parameters that we can play, which is we fix the magnetic field and change the radio frequency, and so our atom can absorb the enough energy to the equal to the delta E to have a resonance. In this case, we can see radio frequency is directly proportional to the B node. This is the two main parameters in the NMR. Which nuclei exhibit NMR phenomena? All nuclei with odd number of protons and all nuclei with odd number of neutrons can exhibit the NMR phenomenon. We can see here, in this example, proton 1 and proton 2 can be detected in the NMR because they have a 1 proton and 1 proton. C13, why it can be detected? Because they have odd number of neutrons. Fluorine 19 because of 9 protons, nitrogen 14 because 7 protons and 7 neutrons. Phosphorus 31 is because 15 protons. All the numbers you can see here regarding the odd number of proton and neutrons. Nuclei does not show the NMR signal is the nuclei that have even number for both proton and neutrons. For example, carbon 12 is 6 protons and 6 neutrons, oxygen 16 is 8 protons and 8 neutrons, and sulfur 32 is 16 protons and 16 neutrons. Even number, they are not detected. So next, why always in the NMR C13 have display the signal compared to the C12 does not? Because in C13 they have a magnetic moments with the I half, and the moment magnet will become positive half or negative half. So they have a spin. In C12, they have no spin, which is I is equal to 0. That's why the C12 does not display the NMR spectrum. Only the C13 had been detected for the NMR signal. In principle, as I mentioned before, they have two parameters that important in NMR, which is frequency and magnetic field. So we see the first parameter, which is magnetic field. We can constant the magnetic field and change the frequency, and our atom will absorb enough radio frequency radiation until it matches the delta E and have a spin flip. Or we can constant the frequency and the magnetic field will be changed until the atom had absorbed enough energy to have a spin flip. So they have two important parameters in NMR principle. What information that we can get from the proton NMR spectra? There are 5 important information that we can get. The first one is number of signal. Number of signal represent how many different environment of hydrogen in the molecule. Next is the position of signal. How we can know through the chemical shift, different position in the NMR spectra. So they tell us what type of hydrogen. And relative abundance under area signal or integration tell us how many hydrogen atom of each type. Splitting pattern tell us the neighboring proton, and coupling constant tell where's the position, whether it's aromatic or aliphatic proton. So this is how the instruments works, where our sample will be inserted in small tube like a pen and will be placed in the magnetic field here in this big tank, and it will be passed with we read it with a short pass of radio frequency, and the signal will be detected by detector, and the NMR spectrum will be appear in the screen. That's all for the principle of NMR, and we will continue with the next session. Thank you.